Okay, in this video we are going to be finding the sine of the difference of two angles. This is going to be a little bit different from the ones that were done last week where we used the unit circle, for example, like the sine of 75 degrees or the sine of 135 degrees. So this is going to be slightly different. So let's read the problem first. It says find the value of the sine of x minus y if the sine of x equals 3 over 5 and the sine of y equals 5 over 13. Now notice that the signs here are given to us in a fractional form, and like I said, this is going to be different from the ones where we use the unit circle. Now, here it says you must first find the other values for the cosines using right triangle trigonometry. We'll get to that in just a minute. First off, we're finding the sine of the difference of two angles, so we're going to use the difference identity for sine, and this is on our blue formula sheet. So we have written here the sine of A minus B equals the sine of A times the cosine of B minus the cosine of A times the sine of B. Remember that A stands for the first angle and B stands for the second angle. So in our example here, we're going to say that X is represented by the letter A and Y is represented by the letter B. Now, if that's the case, A is represented by X, B is represented by Y, then the sine of X is actually going to be the sine of A, and the sine of Y is actually going to be the sine of B. Now, if we go down here to our formula, remember that there's four things that we need. We need the sine of A, we need the cosine of B, we need the cosine of A, and we also need the sine of B. So let's underline what we have so far. We already have the sine of A, and we already have the sine of B. The two things that we are missing are the cosine of B and the cosine of A. In order to find these two things, we are going to use right triangle trigonometry. So we're going to draw two right triangles. So one is over here and the other one's over here. The two angles that we're dealing with are A and B, so I'm going to put an A right here and I'm going to put a B right there. Now we are given two things, the sine of A and the sine of B. Let me write those right here. So we are given, once again, the sine of A. We're told that is 3 over 5. And we are also given the sine of B, and that is 5 over 13. Now, if you remember from right triangle trigonometry, remember that we had the acronym SO, Katoa. What this reminds us of are the ratios for sine, cosine, and tangent. We're not going to worry about tangent for this particular problem, but we are going to use sine and cosine. So this tells us that sine is opposite over hypotenuse. And it also lets us know that cosine is adjacent over hypotenuse. Now, we're given the sine for both triangles, and with going with what we just said, sine is opposite over hypotenuse. 3 is going to be opposite, and 5 is going to be the hypotenuse of the first triangle. For the second triangle, 5 is going to be opposite the angle, and 13 is going to be the hypotenuse. So let's go ahead and label the triangles. Now, 3 is opposite angle A, so this side is opposite angle A. I'm going to put 3 here, and that is the opposite side. Remember, the hypotenuse is always the longest side, so that is 5, and that will be our hypotenuse. We're missing the adjacent side. For this triangle, we'll label it pretty much the same. The opposite side of angle B is 5, so I'm going to put a 5 here. That's opposite. The hypotenuse is 13, that's the longest side, so I'm going to put a 13 right there. That's the hypotenuse. And again, I am missing the adjacent side. Now, we have to find cosine, and cosine is adjacent over hypotenuse. So in order to find the cosine, we need to find this adjacent side. Now remember, if you have a right triangle, what's true for every right triangle is the Pythagorean theorem. A squared plus B squared equals C squared. So let's go ahead and plug in to find the adjacent side over here. And I'm going to use A. So A squared plus, for B, I'm going to use the 3. 3 squared equals, for C, that's always the hypotenuse, so I'm going to use 5 squared. And we'll move that over here for this problem. Okay, so I'll set up this one at the same time as well. We're going to use the same reasoning. So the adjacent side is what we're looking for. That's one of the legs. A squared plus, for B, we're going to use 5 squared. And C, the hypotenuse, 13 squared. So anyway, A squared plus 9 equals 25. And we're going to subtract 9 from both sides, and we find that A squared equals 16. We take the square root of both sides, and we get that A equals 4. So the adjacent side is 4. Now, this triangle over here, we're going to get A squared plus 25 equals 169. We subtract 25 from both sides. We get A squared equals 144. Take the square root of both sides, and you get A equals 12. So over here, the adjacent side is 12. Now, remember, we were doing all of this in order to find the cosine of both of these angles. So over here, I'm going to write cosine A. We know the ratio for cosine is adjacent over hypotenuse. The adjacent side for this triangle is 4, and the hypotenuse is 5. So that gives me the cosine of A. I can underline that. I still have to find the cosine of B. I look at this triangle over here, and I'm going to do the same thing. Adjacent over hypotenuse. So the adjacent side is 12. The hypotenuse is 13. I now have the cosine of B. So, last step, we are going to plug these values into the formula here. So, let's go all the way down here. Sine of A minus B, remember these are the letters that we used. So, sine A times the cosine of B minus the sine of B times the cosine of A. And we're just going to go ahead and plug in. So equals let's do sine A first. So sine A, we know, is 3 over 5. And we put that in parentheses. The cosine of B, we found that to be 12 over 13. Put my minus sign. Sine of B, let's go back up top here. That was given to us as 5 over 13. And finally, the cosine of A, we found that to be 4 over 5. Okay, let's go ahead and multiply here. You're going to multiply straight across, and these numbers aren't really big at all, so you won't need a calculator. Some of the other problems you may need a calculator for, but this you should not. So anyway, 3 times 12 is 36. 5 times 13 is 65, minus 5 times 4 is 20, and 13 times 5, make that 20 a little bit better, 13 times 5 is also 65. Both of these fractions have the same denominator, so we can combine the numerators. 36 minus 20 is 16 over 65, and that is our final answer. You may want to take a look at this video twice and familiarize yourself with all the steps. It does have a lot of steps, but then once you get your numbers, it's pretty easy to plug in and break down. Thank you.